Hey guys, it's Mr. Brian here. In this video, I'm partnering with EduKaji to guide you on the SPM 2021 physics paper. We will be discussing physics paper 2 on structure and assay today. Okay, without further ado, let's get started. Okay, so, sorry, paper 2. This is paper 2, 2 hours, 30 minutes, 100 marks. Question number 1 on heat. The diagram shows a cooling curve for a metal in a liquid state. Okay, so this is our cooling curve. The temperature of the metal is constant from Q to R. State the type of heat involved from Q to R. Q to R is a phase change, therefore latent heat. Okay. Latent heat means when you change phase. For heat capacity, you are trying to change temperature. Change the temperature. This one is change phase or change the state of matter. Then in part 2, name the state of matter from Q to R. Now you read the question carefully because they mentioned this is a liquid state. So therefore, it would start from a liquid and then you are cooling down. You cool down, the liquid will slowly become solid. And then here you're continuing to cool down you're continuing to cool down the solid. So Q to R is solid and liquid. My bad. Solid and liquid, yes. Or liquid and solid. Up to you. Solid, liquid, liquid, solid. Either one. But must write both. That means in between here, there's a mixture of liquid and solid. Okay. And then part 3, give one reason why the temperature is constant from Q to R. For example, if we talk about water, of course, this is not water, this is some metal. If you talk about water and you're trying to freeze the water from liquid change to solid, you're trying to freeze it. The freezing can only happen at 0 degrees Celsius. That's why we call it the freezing point. It doesn't change temperature. It only happens at always the same temperature. When you change phase, temperature won't change. And why temperature is constant? I always say you must remember temperature's best friend is always kinetic energy. If they ask you why temperature increase, you say because kinetic energy increase. If they ask you why temperature constant, you tell them because kinetic energy constant. Usually you will get marked there. These two, they are always best friends. Okay, you tell them because the kinetic energy of molecules are unchanged or remain constant. Also can does not decrease, does not change, remain the same. As long as the same meaning, then it's fine. But B, what happened to the heat energy during the cooling process from R to S? Now, when you're cooling it down, they ask you, what happened to the heat? Actually, for cooling curve, there's not much to say. Here, when you're cooling down, the heat is released. You're cooling. If let's say we are heating it up, then you say, I'm absorbing the heat. The metal absorbs the heat and become hotter and hotter. But right now, R to S, what happened to the heat energy? Heat energy is released. Okay, you can say heat energy is dissipated. Heat energy is lost, also can. There you go. Quite a simple question 1. Question 2, photoelectric effect. The diagram shows an apparatus to study the effect of photoelectric for zinc metal. The electrons are emitted from the surface of zinc metal and move towards the anode. Okay, so how it works is you shine some light at the correct frequency, electrons will be emitted. We call them photoelectrons. Because your anode are positively charged, it attracts the electrons over and you complete the whole circuit. That's why the emitter will have some reading. Okay, what is the meaning of threshold frequency? Remember just now I say when you shine the light, you must make sure the frequency of your light must be higher than a certain frequency. The minimum frequency is the threshold. Threshold frequency is the minimum frequency this is optional of light or of the photon to produce photoelectric effect. So if you never write whatever I wrote in bracket, it's fine. They will still mark it correct. Huh? You must make sure that your light must be higher than this minimum frequency. Then only photoelectric effect can happen. Then only electrons will come out. Okay. Calculate the work function of metal zinc. Given work function is this. Okay, these days we don't really use this Planck constant anymore. Normally they will give you in the formula sheet, but this 2021 paper was like the first paper that had quantum physics, which is why the Planck's constant value is rounded off so much. But usually we use 6.67. Sorry, 6.63, not 67. Sorry, I keep listening to 67 until, okay, 6.6, my bad, 6.63 times 10 to the power of negative 34. But don't worry, you just follow the value in the formula sheet. Okay, so work function is equals to H and then FO. FO is 9 times 10 to the power of 14. Okay. Some of you who are sharp, you might notice a little issue in this question. Okay, answer I got is 5.94 times 10 to the power of negative 19 joules. Okay, some of you might notice a certain issue. Teacher, this one is supposed to be threshold frequency, but the value that they gave is the light frequency. Normally, this is called F, not FO. Which is why I would say, actually, this question got an error. There is a question error. They gave the wrong frequency. They gave the wrong frequency. So in SPM, I always say, you do not leave, especially in paper 2, you do not leave your answer blank. Don't say because you feel like it is wrong. You just do whatever you can. So one of the ways is, some people, they just see, like the whole question is very straightforward. There's no other value that they gave. Just use this one. Okay, we just assume this one is the threshold frequency. Okay, and then you get answer. And then some people will say, oh, teacher, I know because this one is threshold, sorry, this one is the frequency, right? Can I assume another threshold frequency value and then sub in here and get an answer? Can also. You say, because my F is this, maybe you assume, because they didn't give the threshold, maybe you assume FO as a value that is smaller, maybe 8 times 10 to the power of 14, because threshold is usually smaller. Okay, can also, then you sub in, you get a different answer, right? The point is, don't leave it blank. Just do whatever you can. Usually if it's a question error, they will be more lenient. Like even if the idea is wrong, it's still okay. We'll still mark you correct. But I want you to know that there is an error actually. This is F. It's not the same as FO. Tak sama. Okay, but you just do whatever you can. Then in part C, the intensity of light strikes the surface of zinc metal does not affect kinetic energy of electrons. Explain why. Please always be reminded that in this section, they like to test you two things. Intensity of light is kind of like brightness. The intensity affects the number of electrons. Okay, that's one thing. The frequency always affects the kinetic energy. So these two, they are different concepts. How to remember? I tell my students, the letter I stands for intensity, right? The letter N stands for number of electron emitted. So if you shine a very bright light, the light even more intense, more electrons will come out. As a result, it will affect the current also. Because more electron flow means more current. Okay. Then I also tell my students, you can also think for frequency, you can think of freaky. Okay, I know it sounds a bit weird, but it comes from the English word freaky. So similar sound, but the spelling a bit different, where I say the frequency of light always affects the kinetic energy. Okay, another way to remember this is your formula sheet, you will be able to find this E equals to HF. And that reminds us that frequency always affects the energy. Just to connect them together, frequency always affects the energy. Not directly affecting the kinetic energy, but it always affects the energy. Okay, so 2 marks, how do I answer? I'm going to say, you say does not affect kinetic energy. Why? You tell them when intensity of light increases, yes, it doesn't affect kinetic energy. It only affects the number of electrons. Only the number of electrons, or to be more specific, usually in this chapter, we will say photoelectrons. Photoelectrons, electrons, same thing. They are the same thing. Photoelectrons are just electrons that come out because of light. Photo means light. Number of electrons emitted increases. Okay, so you tell them this idea. I know that when intensity increase, it affects the number. Okay, then secondly, what affects the kinetic energy? And the kinetic energy of electrons is only affected by frequency of light. Okay, or frequency of light. You want to write light photon, can also, same thing. Okay, you tell them kinetic energy is affected by frequency. And there you go, 2 marks. Okay, this is how I would explain it. Question number 3. Okay, gravitation. The diagram shows a rubber stopper of mass 0.2 kg is tied to one end of the nylon thread and hung to a load on the other end. The rubber stopper is spinned in a circular path at a constant speed. Based on the diagram, name the force that remains the rubber stopper in a circular path. Anything that go round and round in circle, we call it centripetal force. Okay, the centripetal force, so happened, I was going to talk about part 2. Okay, mark the direction of the force, the centripetal force. Always remember, the force is always pointing to the center of the circle. You don't point outwards, point to the center of the circle. We say that this centripetal force is also equals to the tension of the string or the thread in this case. Okay, it means how hard you are pulling the thread. You see this thread is being pulled by the load. The load is pulling the thread to the center. Okay, but then how come this rubber stopper, it will not get pulled down to the center? Yeah, you think of it. How come this rubber stopper won't drop down? Because this glass tube is hollow one inside. Like the glass tube inside got nothing one. And then the thread gets pulled down by this load. But why won't get pulled down? Oh, because it's moving fast enough. Yeah, that's why in part 3, draw the arrow to show the direction of linear speed. Since they mentioned it is going to rotate this way, right? Your linear speed, you draw something like that. It must be like a tangent to the circle. That means it must only be touching one point tangent to the circle. Okay. Normally, if like they put here, it's easier to draw, you can draw like this, right? But I draw at the rubber stopper here. At this particular point, it will look something like that. Okay, as long as it looks like it is tangent to the circle, then okay, that means touching one point only. You label V. You get 1 mark each. Okay, yeah. So the reason why rubber stopper won't fall down is because it is moving fast enough. So same thing, why satellite that is orbiting the Earth won't get pulled by the gravity of Earth? Not to say won't get pulled. It is always being pulled. It's just that why won't it fall down? Oh, it's because the satellite is always moving very fast. Always moving very fast. So it always maintains the circular path because Earth keep on pulling it, but satellite also keep on running away, keep on moving very fast with a certain linear speed. Okay, part B, the rubber stopper is spin with a linear speed of 10 meters per second. Calculate the force acting on the rubber stopper if the radius of circular path is 1.5 meter. Okay, There is a formula lah, centripetal force, number 3. F equals mv squared over r. Let's do that. F equals to mv squared over r. Did they say the mass of rubber stopper? Yes, 0.2 kg. Okay, this is the V, and then this is the R. Huh? Okay, we get 13.333 newtons. I prefer you to leave it as 3 decimal place. Guys, please don't leave it as a fraction. We will mark you wrong. Yeah, in physics, we don't want final answer in fraction. At maths is fine, but physics, no, be careful. I want decimal. Okay, 13.33. Oh, that's a part C. What will happen to the radius of the circular path when the rubber stopper is spin with a higher speed? If you spin faster and faster and faster, it will swing further and further and further, right? Very logical. You swing faster and faster and faster, it's going to swing further and further and further. So the radius of the orbit is going to be bigger. The radius of circular path increases. Okay, it will increase. It's not quite logical, huh? Question 4. On your transistor, the diagram shows a transistor circuit that consists of a light-dependent resistor, LDR. When the LDR detects light, potential difference of the LDR is 1.2 volts. Okay. State the function of a transistor. A transistor, which is this guy right here, always has only 2 functions in your syllabus. Number 1, we call it a automatic switch. Number 2, we call it a current amplifier. Current amplifier. Now, which one is it? Depends on whether there is a LDR or a thermistor. If your picture got LDR or thermistor, then we always call it an automatic switch. If don't have LDR in the circuit, don't have thermistor in the circuit, then this transistor functions as just a normal current amplifier. It helps to amplify the current for you. Okay, a small base current gives you a very big collector current. Part 2, calculate the resistance of the LDR. Okay, resistance of LDR. Normally, this case, we look at it as a series circuit. We call this a potential divider calculation, which is very popular. Okay, guys, you focus on this green color circuit. Please ignore everything here. Ignore everything here. Okay, don't look at everything inside. Just focus on the green color circuit. Do you notice this is a series circuit? Okay, secondly, if you put 2 resistors in series, their voltage will share. Their voltage will share. Now, how do they share? They always share according to the ratio of the resistance. So this is something you all need to know. Now, how I would do it is just go and write the ratio of the voltage and the resistance for any one of it. For example, since you want to find out the resistance of this guy, right? Let's call it the resistance of LDR. Okay. When I got 1.2 volt, my resistance is a certain value. Okay. Here we do not know the voltage. So maybe you don't go and use this one. But there's one more. When it is 6 volts, 6 volts is the total voltage. Total voltage is 6 volts. The total resistance is how much? It's 10 kilo ohm, sorry, plus R of LDR. Okay, be careful, all the units we are doing in kilo ohms. So the formula actually just looks like this. You take the ratio of the voltage, just divide, equals to the ratio of the resistance. And try to solve the value of R. Done. This is the working. Okay, this is the working. So please understand what I'm doing here is, like I said, you go and write the voltage and the resistance for this guy, or the voltage and the resistance for this guy. Okay, and then in SPM, we always, in our syllabus, in your SPM syllabus, they always want you to go and write the total voltage and the total resistance. How do you add up resistance in series? Series, you just plus only. And don't forget your chapter 3. Series, you just have to plus the resistance. So it's just like that. And then you just divide it as a ratio, a fraction. You can, sometimes some of the, okay, I simplify, instead of R, LDR very long, I just write R. Some of them, they will write like that. They will just multiply the 6, go up. So both also works. Whether you write like this or that, both also can. Either one. Okay, but I feel that this is easier. You can solve 1.2 divided by 6 is 1 over 5. And then maybe I cross multiply. This one I multiply with a 1. I will get 10 plus R. This one I multiply with a 5R. I will get 5R. Okay, R you move over become minus. 5R minus R become 4R. 10 divided by 4 is your answer. I get a 2.5. But be very careful. What is the unit? Kilo ohm. In a LDR circuit, we normally like to use the values in kilo ohms one. Okay, 2.5 kilo ohm. That is my working. Done. Okay, can. So I'm gonna move this down here. You do like that. Okay. This is the working. Okay, 3 marks. Not bad. As long as you understand that right now we are splitting up the voltage. Okay, by the way, sometimes they can also ask you, okay, so we found out that the resistance here is 2.5 kilo ohm. Okay, but guys, can I ask you a simple question? If right here is 1.2 volts, what is the voltage for this part? Remember just now I say, in a series circuit, voltage will share. Down here is 1.2. Up here, it must be 6 volts, which is the total voltage, minus 1.2. You will get a 4.8. So actually, if I want to find out what is the voltage here, I would also know it is 4.8. 4.8 plus 1.2 is equals to 6. You get what I mean? So the 6 volt will split up to these two guys. Okay, and then part 3, calculate the amplification factor. To calculate amplification factor, you need to know 2 things. One is your base current. One is your collector current. We call this the IB, and we call this the IC. In your formula sheet, don't need to worry. Got formula. In your formula sheet, amplification factor is IC divided by IB. Just like that. Okay, so I do it here first. IC divided by IB. Amplification factor is 5 milliampere. This one need to be careful. Milli is 10 to the power of negative 3 ampere divided by 50. This one is microampere. I also need to be careful. Negative 6. You must make sure you convert to ampere or else the unit cannot cancel. Okay, so be careful on that. Once that is done, that's why amplification factor don't have unit one. Please don't write any unit. You write ampere, then wrong already. Be careful, 100. That's why we say transistor is amplifier, current amplifier also, because I only need a very tiny base current, 50 micro, very small only. It will give me a value that is 5 milliampere. So it will help you to multiply, in this case, 100 times. Okay, it will help you to multiply the current by 100 times. Hence, we call it current amplifier. Okay, then part B, explain how the bulb in diagram 4 light up when the surrounding is dark. Okay, when the surrounding is dark, maybe I do here first. Always remember, whenever it's cold or nighttime, I always tell my students this, cold or nighttime. Cold is talking about temperature. Nighttime is talking about the light intensity. How bright is it? During nighttime, the LDR resistance will always increase. When it's cold, the thermistor, if you're using a thermistor, resistance will increase. You see? So cold night, LDR thermistor will increase. The opposite of cold night is hot day. When it's hot, thermistor resistance will decrease. When it's daytime, very bright, all this resistance will decrease. Okay, so how to turn it on? First step, you explain. When it's dark, resistance of LDR increase. When resistance increase, voltage at LDR, which is the same thing as the base voltage, will increase. In case you all don't know, we call this the base voltage. The voltage right here is the base voltage. Down here is called base. Down here is the base circuit. Okay, so the moment this guy has a high enough voltage, then current will start to flow through the blue color one. So please understand, at first, current flow through the green color one first. Green color one is number one. Sorry. Green color one is number one. Then the moment the voltage is high enough, current will flow through the blue color one. This is number two. And then transistor will turn on as a result. When transistor turn on, then you will have lastly this orange color current flow. Okay, we call it the collector current. And so the bulb will light up. So in normal case, what if the base voltage is too low? Then the blue color one will not flow. If the base voltage is too low here, blue color one cannot flow, transistor will not turn on. This bulb also won't light up because the collector current won't flow in through the orange color part here. Okay, so please understand that in any automatic switch circuit, our goal is to make the base voltage be high enough. Now, how high is it? Depends on the transistor. So like, for example, if I'm using a silicon transistor, this one extra knowledge. If I'm using a silicon transistor, then usually I need a base voltage of roughly around, at least around 0.7 volts. Okay, but don't have to memorize this number. So you just think there's a minimum value, there's a minimum voltage. You must pass that minimum value, then only the base current will flow. Then only this blue color one will flow. Then only transistor will on. Then only this orange color part will flow. Then only the bulb will light up. Okay, so that's the idea. We're gonna explain. Honestly speaking, 3 marks is quite easy to get if you understand the concept roughly. The points are very short only. When surrounding is dark, resistance of LDR increases. When resistance of LDR increases, base voltage, the voltage of the LDR, the base voltage, increases. When base voltage increase, the moment the base voltage is high enough, the voltage at the LDR here is high enough, then current will flow. This current is called the base current. Base current flows. Then transistor turns on. The base controls whether transistor can turn on or not. Turns on, or you can say is activated. And then collector current flows. which is why the bulb light up. Okay, you don't have to copy again, bulb will light up lah. So like this will do. I can ask you 4 marks. You can also get 4 out of 4. I can ask you 3 marks, you will get 3 out of 3. Right? So any 3 out of 5 points here, you got it. It is full marks already. Yeah, any 3 out of 5. And question number 4. Number 5. This one on waves. Diagram shows water waves produced when a boy continuously dips his feet in the water in a constant rate. Take the correct answer in the box provided. Water wave is transverse. Longitudinal only got one. Sound wave. Only need to remember sound wave. Sound wave can come in many ways. Ultrasound also is sound wave. Ultrasonic wave is the same as ultrasound. So sometimes they change the name a little bit. Any kind of sound wave is longitudinal. Everything else other than sound, transverse. Okay. Part B, observe diagram 5.1. Compare the region X and Y in terms of depth of water, wavelength, and frequency. Okay. Depth in X is smaller than Y. X smaller than Y. Depth of water in region X is smaller than region Y. Some of you will say, teacher, my school teacher don't like this, don't allow me to write this. Then you write is less than, is smaller than. Okay, it's less than. It's smaller than, it's fine. Teacher, my school teacher say must copy the question. Must write depth of water here. Depth of water in region X. Okay, so how? In SPM, structure questions, I always say this whenever I discuss SPM papers. In SPM, if you write exactly like how I did, already correct. Can you instead of writing this, write is smaller than, is also correct. Teacher, if I'm scared, can I copy this one? Is also correct. Whether you copy the depth of water or not in a structure question is fine. You want to copy, you copy. You don't want to copy, you just write like that, also fine. Why? Because the question is right on top, so it's fine. Okay, but essay question later, you will see I will copy. Section C later, got one comparison question also. You must copy. Essay question, you must copy. Okay, but this one you never write. Is it okay? Yes, it's fine. But if in your trials exam, your teacher already say must copy, then you copy. So if you are not sure, the full version is you just write. Some teachers want you to write what can I do, right? So you have to write they are the one marking your school papers. Depth of water in region X is smaller than region Y. Okay, but how I write it in SPM is already correct. And then you can compare the wavelength. Wavelength, okay, this one a bit hard to see, but you will notice this one is closer a little bit, while this one is further one. It's always like that. Yeah. Wavelength in region X is smaller than in region Y. Okay, the frequency of water waves must be the same. How do I know the frequency is the same? Because the boy keep on dipping his feet with a constant rate. So that is one thing about, this is refraction of water waves, where I always say, the main thing you learn is very straightforward. Just make sure you know, if the depth of water increase, it always means the speed increase and the wavelength increase. If decrease, everyone will go decrease. So normally in short, I like to say this, refraction. Depth increase, speed increase, wavelength increase. If decrease, okay? And then another thing is, make sure you must know the frequency unchanged. Why? Because if you dip your feet up and down at a rate of, let's say 2 Hertz, that means he dip his feet twice every 1 second. 2 Hertz means twice every 1 second. It means here also is 2 Hertz. It means the deep region here also must be 2 Hertz, because frequency is affected by the source of the wave. the source, his feet. If his feet keep on dipping at the same rate, that means it will not affect the frequency one, unless he start to dip faster. The source is his feet. Unless he start to dip faster or slower, then it changes the frequency at the source. It will change the frequency here, will change the frequency here. So the source, the same frequency will always be the same. You know? And then relate wavelength with depth of water. It looks like if it's smaller, then smaller lah. Okay. Can I say the depth of water first? The smaller or the greater also can. The depth of water, the smaller or the shorter the wavelength. Or you can say, if one increases, the other one increases. Yeah, also can. If you want smaller, you write the greater, the greater. Same, huh? The name of the wave phenomenon is called refraction. Okay, refraction of water waves. But E, the diagram shows propagation of waves from deep water region to shallow water region as towards the headland that happens in the sea area. In the diagram, draw the direction of the propagation when the waves approaches the headland. The headland has another name. In BM, it's called Tanjung. Yeah. This is usually called the Teluk, okay, which is the bay area. Tanjung, sometimes they'll call it the Cape area also. Okay, headland has another name called Cape. Okay, so they ask you to draw the waves. So this is testing you. Do you know that when it's very far away here, the region is quite deep, but when you go closer and closer, it becomes more shallow. Okay, it becomes more shallow. So as the depth gets decreased, as the depth decreases, the wavelength would decrease. But in this picture, they never show very clearly lah. Yeah, the wavelength look quite similar. Okay, this is not a very nice picture, if I were to be honest with you. But they ask you, draw the direction of propagation. They want to see, do you know that the wave are all going to focus mainly on the headland? Something like that. Okay, minimum you draw 2 arrows, good enough. But you will all focus at the headland. You might be thinking, teacher, why you never draw straight? Because if I draw straight like this, the direction and my wave is no longer forming a 90 degree. 90 degree must be a nice L shape. Guys, this is not a 90 degree. Can you see? It's very sengit. Okay, not a 90 degree. 90 degree must get a perfect L shape. Which is why when I bend like this, right? You see it forms a L shape, a nice 90 degree. Kind of lah, right? Don't have to be too perfect, but as long as we can see it is bending towards the headland, then correct already. You want to draw more arrows also can. 5 arrows, 6 arrows, up to you. But minimum 2. Okay. Then in part 2, they say, in the shallow region, the wavelength and speed of water wave is this. Calculate the speed in the deep region when the wavelength is 20 meters. Now, this is a very good question because if you go and look at the formula sheet, you see wave only got 2 formulas. One is the interference one. One is V equals to F lambda. Like that only. Then you see the information that they give you is a bunch of wavelength and speed. Okay, this one is the wavelength. Maybe I call this wavelength in the shallow region, speed in the shallow region. This one is in the deep region. Okay. All right, small letter, easier to see. Deep region. Okay, I want to find the speed in the deep region. Okay, so we got V lambda, V lambda. Well, it looks like maybe I can use this, huh? But considering all the V and lambda, actually, they want you to do this. They want you to use this. Now, the next question is just talking about whatever I explained earlier. Do you know that the frequency in the shallow region and the frequency in the deep region must be the same? If 2 hertz, here also will be 2 hertz, here also will be 2 hertz. That is what we are trying to say. Understanding that frequency is the same would then tell us what is frequency? Frequency is V over lambda, which is why I would say the V over lambda for the shallow region must be equals to V over lambda for the deep region. This is the formula that we are going to use. Okay. Sometimes people will write it as 1, 1, 2, 2 lah, up to you. Same. I write shallow, shallow, deep, deep also can. So we sub in 2.5 meter per second divided by 8 meter equals to speed in the deep region divided by lambda 20 meter. Okay, multiply. 2.5 divided by, divided by 8 multiplied by 20. I get answer 6.25 meter per second. Use the same unit. Left side, right side will be meter per second. Left side, right side will be meters. Okay, there you go. That is question 5. Okay. Question 6. Diagram shows a copper wire in a magnetic field swings when the current flows through it. Name the rule used to determine the direction of swing of the copper wire. I always say if you're thinking whether is it Fleming's left or right hand rule, you write down FBI. You write 3 letters, and then you see in this picture there's magnet. B is a magnet. You see in this picture got current flowing. You're trying to find out what is the force that causes the movement of the copper wire. You're trying to find F. When you try to find F, F is on the left, right? If you are trying to find I is on the right side, right? You get what I mean? These 3 letters, who is the letter on the left? F is on the left side, I is on the right side. So if you're looking for current, induced current, I use Fleming's right-hand rule. If you're looking for force, I use Fleming's left-hand rule. Another thing is, guys, Fleming only has 1 letter M. Be careful of the spelling. You can write all small letter also fine, it's okay. Okay, Fleming's left-hand rule. Compare the thickness of the copper wire. Diagram B is greater thickness. Or you want to say diagram A is smaller thickness, up to you. Diagram 1, maybe I say B, thickness is greater than diagram 6.1A. If you don't like the symbol, you go and write is greater than 3 words only. If you feel like, teacher, I want to copy this, can or not? Can you go and copy, is also fine. But if I wrote like this, I will already get correct in SPM. Okay, and then part 2, the size of the swing angle of the copper wire. In the second picture, you can see it swing higher, meaning there's a sign that it has more force. Okay, more force. This one less force. So 6.1 B is greater. Or 6.1 A is smaller, also can. The force acted on the copper wire. Because force is greater, that's why swing higher. This is what I just said. So again, B is greater. Then state the relationship between force and the force acted on the copper wire and the thickness. Okay. It's because you have greater thickness, therefore you have greater force. So I feel it is better for you to write the thickness first. Yeah, I feel the thickness affects the force. So I feel thickness first would be better. The greater the thickness of the copper wire, the greater the force acted on the copper wire. Okay. Size of swing angle and the force. This one, either one, you write the force first. Because I got greater force, then I got bigger size of swing, also can. Or you write, because I got bigger size of swing, therefore I know that it has a bigger force. Up to you. Either one. This one doesn't matter. Maybe I follow like just now I write the size of swing first now. The greater the, this one terbalik is okay. But in SPM, right, even in part 1, you terbalik the force and the thickness is also okay one. We will still mark you correct. It's just that in school exam, usually sometimes some teachers will mark you wrong because we prefer you to write like the manipulated variable first. Thickness affects the force, not force affects the thickness. Right? So if you know which one comes first, right? If you feel like both also can, like in part 2, then it's fine. Okay. The greater the size of swing angle, of copper wire, the greater the force acted on the copper wire. Okay, so the whole idea is like this. Because you use a thicker wire, the resistance of the wire is lower, therefore there is more current flowing through. Right? Since there's more current flowing through here, it means that the interaction between the magnetic fields. So your north and south got some magnetic field. Your current carrying wire, your current carrying conductor, this piece of wire also got magnetic field. They will interact with each other. The interaction produces that force, which is why your swing is so high. Okay, that is the idea. Then part D, if the pole of magnet in diagram B is reversed, what will happen to the swing of the copper wire? If you terbalik the north and south, terbalik the pole, then of course it will swing the other way, right? Or they ask, if you terbalik the current, then it will swing the other way, it will swing to the left side. Okay, but you can try and see why this one makes sense. You use your left hand. By the way, don't follow my video because my students always say, because maybe the video is like terbalik, is mirrored, so it looks a bit confusing. You can try and see using your left hand. My watch, I always wear my watch on my left hand, so my watch hand is my left hand. And I'm gonna do index finger first. Let's try and see the original question first. We always point to south. So your index finger point down, left hand point down. Okay, index finger pointing down. North always pointing to south. Then your middle finger, your current, is coming out, pointing out from the paper. So it's coming out from the screen. You can't really see. My middle finger is coming out, pointing at me, coming out from the screen, pointing at me. So index finger down, current direction is pointing to myself, coming out from the screen or coming out from your book, and your thumb is pointing to the right side. This is what I get. Okay, so memang correct. My force is memang gonna be pointing to the right side. Now you terbalik the north and south 100%. You can try again if you want. It'll be pointing to the other way. Okay, so you can say it will point, what happened to the swing? It goes to the opposite direction, it goes to the left side, or it swings inwards, also can. Inwards into this C-shaped box here. It swings opposite direction. Or to the left also can. Or if you say swing inwards, also they accept. Okay. In part E, the copper wire is then replaced with a coil. Instead of one wire, okay, we use a coil. When the switch is on, the coil will rotate in one direction. Mark the direction of electric current in the coil. You just follow the sign here. Done. Okay, current direction. You get 1 mark for this. And then state the direction of rotation of the coil. Guys, for rotation of coil, always got two answers only. Either clockwise or anti-clockwise. Just like in maths, how do you do rotation? Either there's clockwise or there's anti-clockwise. I tell you, clockwise or anti-clockwise. So this one, direction of rotation, how to figure out, you focus on either one of the wires. You can look at either this green color wire or let's say this orange color wire. Again, you try your Fleming's left hand rule. My watch hand is my left hand. Don't follow my video if it's confusing. You try yourself and see. But index finger first. Index finger is your magnetic field finger pointing to south. And then I'm doing for the green color one. The current is pointing, this one, your hand will be a bit weird. Your current is pointing sorry, not pointing out, pointing into the screen or into your book. And your thumb will be pointing to the right side. You try and see whether you can get a force. This one pointing to, not the right, the left, my bad. Okay, you try and see. Your hand will be in a bit awkward position. This one. And then you try and see the orange color one. Index finger point down to south. Current is pointing out from the screen. Point out. So the middle finger is pointing at me. Point out from the screen, pointing at me. And my thumb is pointing to the right side this time. You see whether you can get something like that. So it will rotate one to the left and one to the right. That's why it will give you a continuous rotation. This is exactly how a fan would rotate. You put these two together. One rotate like that. Another one rotate like that. Okay. Guys, this is called anti-clockwise. You're thinking, teacher, how you know anti-clockwise or clockwise? How do you see? There, guys, you draw the clock. This is 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, right? Not? You can continue. But do you notice you're going 4 o'clock to 3 o'clock to 2 o'clock to 1 o'clock? 4, 3, 2, 1 like that. If you're going against the clock, that one is called anti-clockwise. If you follow the clock, 1 o'clock, 2 o'clock, 3 o'clock, guys, these numbers are the clock numbers, 1 p.m., 2 p.m. Okay, you follow the clock direction, then it is clockwise. But right now it is anti-clockwise. Okay, so the answer is a simple anti-clockwise. Okay, done. That's the answer. That's question number 6. Okay, question number 7. Nuclear physics. The diagram shows a nuclear reactor that generates electrical energy through nuclear fission reaction. What is the meaning of nuclear fission? Nuclear fission keyword here is the word split. You got a heavy nucleus split into lighter nuclei, and at the same time it will usually release some neutrons, but that one not so important. And it will also generate a large amount of energy. It will produce a large amount of energy. Okay, that is fusion. Fission, sorry. Fusion, on the other hand, is keyword here is fuse. So you focus on, you got two lighter nuclei fused together to become a heavier nucleus, and in that process releases a lot of energy. Okay, so I say it is when a heavy nuclear fission is a nuclear reaction where, okay, maybe I write in full. A nuclear reaction, if you didn't write this, it's fine, where a heavy nucleus, not atom, nucleus, splits into lighter nuclei and release a large amount of energy. Okay, so whatever I put in bracket, even if you didn't write, it's still okay. But what is important is this. Okay, this part very important. The back part, depending on the schema, sometimes in some SPM paper, they are not so strict. They're okay with you not writing the energy that part. Okay, but a lot of state papers normally they want you to write the large amount of energy. And this one lighter nuclei, sometimes they want you to write like into two or more. Yeah, two or more lighter nuclei. But nuclei already means it is plural, lah, right? Which already means it is two or more. Nucleus means it's one only. So one split into two or more. That already makes sense. Sometimes it can be two, sometimes it can be three, can be four also. Okay. Part B, the nuclear fission reaction occurs in the nuclear reactor in diagram 7, represented by this equation. The mass defect produced from the nuclear fission is given. Calculate the mass defect in kilograms. Okay. You don't have to worry about the conversion. U stands for, U is the short form for unit or atomic mass unit. AMU, atomic mass unit. Some students, they call it AMU. Okay. You take a look at the conversion in the formula sheet. SPM will give you 1 AMU is 1.66 times 10 power negative 27. You just follow. So my mass defect is 0.198264 times 1.66 times 10 to the power of negative 27. That will convert it to kg. I will get 3.291. 3 decimal places is enough. You want to write more, it's also okay. Times 10 to the power of negative 28 kg. Okay. Then calculate the nuclear energy produced in the nuclear fission reaction. This time we take a look at this formula, E equals to mc squared, but you will need the c value, which is the speed of light, at 3 times 10 to the power of 8. Okay, E equals mc squared. Quite easy lah, the calculation in this nuclear physics chapter usually. Mass is 3.291. The C value is 3 times 10 to the power of 8. So don't forget to square. Okay, I get 2.962 times 10 power negative 11. Yeah. I rounded off. I get 9619 or 962 is okay. So depending on what value you use, some of you all maybe write a decimal here. Maybe when you sub in, your answer is slightly different. Maybe it's 2.961. Also can. The unit will be joules. Guys, I want to remind you, if you want to get joules, you must make sure this is in kg. It cannot be in AMU. Must be in SI unit. And this one is memang SI unit. Don't have to worry. Speed of light. Okay, it must be kg. Then only you can get joules. Okay. Part C. The table shows different characteristics of a few reactor models that is built to generate electrical energy in the industrial area. Based on the table, state the suitable characteristics. Control rod, moderator. Now in the picture here, you see control rod is all these rods. Okay, moderator is right here. And then you got some uranium field rod. Now I always tell my students, you must know this. Number one is we use we buy CD to control airports. I know it sounds very weird, but B stands for boron. CD is the symbol for cadmium. Control rod. A is to absorb. Okay, another one that you need to know is graph. I know it doesn't make sense. Really, it truly doesn't. But I've tested many years with many of my batch of students, and they always somehow remember this. Graphite. And guys, honestly, these days, a lot of things also don't make sense, like 6, 7, right? You know what I mean? So like, as long as it sticks to your head, that is what is important. Graph stands for graphite. Mo here stands for moderator. Slow here stands for slow down. Okay. Now, if you know a little bit of things about this nuclear reaction about a nuclear reactor, you would know that to control the rate of reaction, we need these two things. To make sure that this reactor doesn't become like an atomic bomb, right? Because when do we get an atomic bomb? It's actually very similar to your nuclear reactor. We get an atomic bomb and it will explode when we cannot control the reaction. So we use these two things to control the reaction. One is control rod, one is moderator. And to control the reaction, you always have to deal with the neutrons. Because the neutrons, they are the one responsible of bombarding the uranium. And it causes it to split up into lighter nuclei. And then it will at the same time produce more neutrons. The neutrons will continue to then bombard other uranium. Bombard meaning keep on shooting other uranium, and then it'll cause it to split more. So neutrons are the one that keep on hitting uranium, bombarding the uranium and split, bombarding uranium and split. That's why you either want to absorb the neutrons or you want to slow down the neutrons. That is how we control the rate of reaction to avoid this reactor from becoming an atomic bomb. Okay, the problem is a lot of students always mix up the difference between absorb and slow down. They don't know, they forget control rod or moderator, which one is to absorb the neutrons, which one is to slow it down. So this is the way to help you to remember. And also the material to use for control rod, the material to use for moderator. From here we know. Okay, so control rod, we do boron. Moderator, we do graphite. Answer is K. Okay, control is boron. Best answer, in my opinion, is to absorb excess neutrons. Any extra to absorb. Okay. And then moderator, graphite. Reason to slow down. This is an optional word. Fast moving neutrons. Okay, done. Correct. Answer is K. The most suitable reactor model. Answer is K. Yeah. Other than writing absorb excess neutrons, slow down the neutrons, is there any other things that you can say? Can also, like this one, if you forget about absorb excess neutrons, you can also say to control the rate of nuclear fission reaction, control the rate of reaction, usually still okay. Or this one, if you forget about slow down, but your answer still need to be related to this. Other than slow down, you can say reduce the velocity or control the velocity of the neutrons. Or control the kinetic energy of the neutrons. Yeah, it must be something to slow it down. Slow down is related to speed. And then the speed is related to kinetic energy. So all related one. So no matter what, you still need to know the purpose of the moderator, the purpose of the control rod. Knowing these two, you will know already how to write. Okay, question number 8. A light question. Diagram shows a ring that consists of a gemstone. The gemstone sparkles. State the physics phenomenon involved. It's called total internal reflection. If you're wondering, why is there a total internal reflection? It's because light would enter this piece of gemstone or a diamond, and then the light gets stuck inside, and then it cannot come out. Gets reflected internally. Then finally only it will come out, let's say. But because it is stuck inside, when you look at this diamond or when you look at this gemstone, it looks very shiny. It looks very sparkly. It looks like a ball of light stuck inside. That's why very shiny. Yeah. Okay, part B. Refractive index of gemstone is 1.5. Calculate the critical angle. This one. They give you refractive index, find critical angle. Quite straightforward, huh? This is the n value. You can multiply the sine C. You can divide the 1.5. C equals to, you type in your calculator like this. Okay. Shift sine 1 over 1.5. Answer is 41.810. Okay. Normally, I like to write 3 decimal in physics. Okay. Okay. Part C. If the gemstone in diagram 8 is less sparkly, state some characteristics to replace the gemstone to sparkle more. Number 1, critical angle. I want it to be small. Smaller is okay, or low critical angle. Why? When critical angle is small, more total internal reflection can occur. Let's say you don't know why. For total internal reflection to occur, we must always make sure that the incident angle is bigger than the critical angle. But let's say if your critical angle is too big, very big critical angle, then it's very hard for your incident angle to have total internal reflection. Okay, maybe I give you one simple example. Let's say my critical angle is very big, 60 degrees. Okay, if my incident angle is 10 or 20 or 30, 40, let me show you, 50, 60, 70, 80. Later we will see which of the following incident angle can have total internal reflection. Okay, you know what? I'm going to copy this and then show you what happened if I change my critical angle to a lower to a smaller and lower value. Let's say 30. Okay, so remember, for you to have total internal reflection, your incident angle must be bigger than critical angle. So is 10 degrees bigger than 60 degrees? No, total internal reflection cannot occur. 20 degrees smaller than 60. It must be bigger, cannot be smaller. Smaller, so all this will not occur. Even this one also we consider won't occur because it's right at 60. But the moment it is bigger, incident angle bigger, total internal reflection can occur. This one also. So this is what you get when you have a very high critical angle. But what if your critical angle very small? 10 degree cannot, 20 degree cannot, 30 degree also cannot, but 40, 50, 60, 70, 80 all can. Because all of them are bigger than the small value of 30 degrees. So you set your critical angle lower, you use a type of diamond or gemstone which has a smaller critical angle, which as a result would make more total internal reflection occur. So it will look very shiny. Okay, optical density is also related to this. I want high, you write higher also can, right? Just now small, smaller, low, lower also okay. Why? Because when optical density is high, it means refractive index is high. When refractive index is high, it means critical angle is small because they are all related to this formula. Okay, but this one you need to know lah. Denser always means bigger n value. Higher density always means bigger n value. Bigger n value always means the C value is smaller. So you say that would mean that I will have a higher refractive index. Correct, you already get marked. Or that would mean that you will have a smaller critical angle. Also correct, also can get marked. Or what if you repeat again? More total internal reflection can occur. Also can. They're all related, right? And the surface of the gemstone, this one a little bit okay, but I want an even surface. You ask yourself, diamond always very smooth. The surface won't be rough. right? It will be even or very smooth also can. Because when it's very even, very smooth, this one is rough or uneven. If you got a very uneven surface, the reflection is very hard, very ugly inside, and it's all very messy inside. And also, a lot of the light, because it's uneven surface, they will just refract out. Okay. Meanwhile, even the critical angle is very predictable. Like you shine light in a certain angle, certain angle, it will all reflect very evenly. So it creates a very shiny diamond. Okay, an even surface also means more reflection inside. Okay, total, I forgot the word internal. And I get this quite often. Teacher, can I write the same reason 3 times? You can if you feel like that is the best reason. If that is the best reason, you can. Okay? If that is the best reason, you can. Yeah, no problem. In SPM, you can write that. Okay. And then now, section B, essay question, finally. Okay. It's a 2 choose 1 section. But let's see. The diagram shows a painting hung on a wall with strings. The weight of the painting is 15 newtons, and each string can withstand a maximum force of 10 newtons. That is the weight of the painting. Every string can tahan a maximum force of 10. What is the meaning of weight? Okay. A lot of people always forget weight is a force. Weight is always in newtons. That's why it's a force. And weight comes from gravity. So you put these two things together. Weight is a kind of force, and it is because of gravity you have weight. It is gravitational force. Just 2 words. It is gravitational force. We say it is the gravitational force. This part is optional, but if you remember, you write I feel it's more complete. Acting on an object. So different object got different gravitational force, got different weight, but it is how the earth is pulling you. Right now, they say this painting has a weight of 15 newtons. Okay, in part B, a few seconds after the painting is hung, it is found that the strings of the painting is snapped. Snap, that means will break. By using the value of angle theta equals to 30 degrees, calculate the tension of the string and also the resultant force. Then, explain why the spring of the painting was snapped. Okay, we calculate the tension and the resultant force first. The tension looks like this. Okay, guys, don't forget, why I draw the tension pointing up is because it doesn't mean that there is no tension pointing this way. There is. Tension always points both ways. But whenever doing all these kind of force questions, you will always ask yourself, what is the tension that is doing the work? What is the tension that is pulling the painting up? Keyword here is pulling it up. The tension must be pulling. I mean by T-shape. Your tension is like this. Or the other one, your tension look like this. Right? You split it up into a T-shape, meaning your force can always become like that. If you split it up, which means it can actually look like this and like this. This force also the same. Like this and like this. When I say T-shape, that means I don't want any force that is senget one. I want all the force either point up, point down, point left, point right. Okay, so another thing you need to know is how to split or resolve your forces. This is T cos 30. This is T sine 30. Those of you who are not good at this, you think T getting closer to 30 degrees. T, right now, you want this T to come closer to the 30 degrees so that it can come down here. What do? You say T go closer to 30 degrees to come down to here. Okay, so cos means it's closer. Sine means it goes away. How does your T go over to here? In order for T to go to here, you need to ask the T to run away from the 30 degrees. 30 degrees is down here, you know. This is the 30 degrees. Do you see the T is running away from the 30 degree? 30 degrees down here, and it's getting further and further and further and further away. T go away from 30 degrees. T go closer and closer and closer to the 30 degree. That's why T cos T sine. That is how I teach my students to remember lah. Like, why is it like that? I really don't want to waste too much time to explain, you know. But knowing this is usually good enough. This again is T cos 30. This is T sine 30. The next thing is, so I do my working here now. The next thing is, you always go and equals all the force pointing up must be equals to all the force pointing down. At first, when you hang this painting on the wall, we say all the forces, they are in equilibrium. That's why you can hang the painting. All the forces are in equilibrium. That's why the painting can stay there. But after a while, we notice that maybe the string cannot tahan the force, so the string will snap, the string will break. But before that, all the forces pointing up, do you notice you have two of the T sine 30? Look for every force pointing up. You can now ignore this one already. Don't need to look at this anymore. What is the forces pointing up? T sine 30 got one, and then got another one, T sine 30. What is the force pointing down? 15. Okay, how to find the T? To find T, you take 15, you divide by 2, and then you divide by the sine 30. You still get 15 newtons. It's just a coincidence. The tension is 15 newtons. But guys, this is not the only way. There is another way, which I call the triangle method. Yeah, so this method, I call it the T-shaped method, where you change all the forces into forces that either point up, point down, point left, point right. And everything up and down must be equal. Everything pointing to the left and right must be equal if they are in equilibrium. Okay, another way is that you can go and draw the triangle. You go and draw these three different forces that you have. So what you do is, you copy these three purple color forces. There's two T and there's one W. W is pointing down. Maybe I draw the W like this. Then I would follow by drawing this T. Guys, I'm going to copy this T and paste here. Copy and paste. Don't draw like that. Don't draw like that. How does this T look like? It looks something like this, right? So when you draw, you also draw roughly the same. Learn to copy and paste. Okay, finally. Okay, wait, I think a bit stretched. Something like that. Finally, I'm going to copy this T and paste here. Does it matter which T you copy first or paste first? No, your triangle can look a little different, but you're just copying and pasting it. Okay, you're just copying and pasting it. Right now, you know the W is 15 Newton. Okay, another thing you need to learn how to transfer is the angles. If this is 30 degree, guys, just now when you copy this T here, please watch carefully. This 30 degree will come here. Can see? This 30 degree is this 30 degree. They are the same. The issue is, we don't really need this 30 degree usually. Instead, what we want is the angle inside of the triangle. If that is 30, here has to be 60, because this is a 90 degree. You get what I mean? So you copy and you paste. Now another one, this is even more tricky. Do you see this is a 30 degree? This 30 degree, watch carefully, this 30 degree will come over here. I copy and paste. Copy, drag over and paste. If you cannot get it, you rewind the video and you see again. Okay, but in short, this is 30, which is very unuseful. But I always tell my students, you learn in from one parallel lines, where if you have a Z shape, that 30 and this 30 will be the same angle. And again, if you know that is 30 degree, what is this? 60. Yeah, so the triangle method is quite long in a sense, but sometimes they will force you to draw the triangle. They will ask you to go and sketch the triangle and ask you to label the angles. So you must learn how to, you need to have this skill. You need to learn how to draw. Sometimes they can ask you to draw. And it can cost like 3-4 marks, 2 to 4 marks. Finally, I rub this off. If here's 60, here's 60. Inside a triangle is 180 degrees in total. 180 minus 60 minus 60, you will still get a 60. Okay, you will still get a 60. So without doing any working, guys, can we say that this is an isosceles triangle? Earlier on, how we get 2 marks? Here 1 mark, here 1 mark. Now, you draw this, you get 1 mark. And then you know that it is a, sorry, not isosceles, equilateral triangle, my bad. You can straight away say 15 must, T must be equals to 15. Because all the angles the same, all the lengths should be the same. If you don't want, you feel scared, you feel like, teacher, I want to prove it out to them. Then you go ahead and prove. Let's say you do not know what is the T yet. You go and use sine rule to do it. T and sine 60 is one pair. 15 Newton and sine 60 is another pair. This one is your admets. Can use sine rule in physics? No problem. Do you see the sine 60 will cancel? T is still equals to 15 Newtons. Also can. I can still mark. If you do like that, I can mark here also can. If you got the drawing, I'll mark at the drawing also. But to do this method, you need to have the drawing. You need to have the triangle. Don't tell me, teacher, the triangle, why cannot just look at this one? Hello, is this triangle the triangle of your forces? Is this a force? No, the triangle has to be formed with 3 of the forces from your picture. Do you see they're all the force? W is pointing down. This T is pointing this way, so I point like that. The other T is pointing like this, so when I draw the T, it is also pointing the same way. You are copying and you are pasting. Okay, okay, so we found the tension, and then they ask, what is the resultant force? The resultant force is actually equals to 0. There should be no resultant force. But don't say, teacher, I thought the painting will fall and all. Yeah. Yes, the painting will fall later. But when you hang it that time, they're all in equilibrium. Yeah, they're all in equilibrium. That's why you could do all this working. Because you know that they are in equilibrium. You know that the force pointing up and down are equal. That's why there's no result. The resultant force is 0. Okay, you get 1 mark here. And then lastly, they ask, explain why the strings of the painting will break. There's one important sentence earlier. You read here, each string can withstand a maximum force of 10 Newton. Every string can only tahan 10 Newton. So my answer is because the tension is 15, but every string can tahan 10 only. You just tell them that. Tension is 15, I found. But by right, the string can only tahan 10. Okay, so I say something like this. The tension of 15 Newton is higher than or exceeds also can the maximum force it can tahan. The maximum force it can withstand of 10 Newton. Okay. Basically you say lah, in short, the T that is 15 Newton is bigger than 10. That's why it will break. Just say something like that. 15 higher than the 10, then okay. This is your explanation. That's why it will break. Okay, Ken. Then part C. The painting is broken when it drops from a height of 4 meters. By ignoring air resistance, calculate the time taken for the painting to reach the floor. Okay. Painting will drop 4 meters. That sounds like the displacement. Okay, calculate the time taken. Some people, after looking at all this, they still don't really know what is going on. Guys, this is what I call a SUVAT question, because I know at the start, my initial velocity is 0, right? It is, the painting at first is resting, and then it will start moving, right? If you don't know what is SUVAT, S-U-V-A-T, SUVAT, it's all this, I'm trying to find the T. My U is 0, my S is 4 meters, and then my acceleration, or we can call it the G value, the gravitational acceleration is 9.81. Why? Because painting is falling down with gravitational acceleration. We ignore the air resistance. So in your SUVAT, there's always one that you ignore, that you don't have. I don't want the V, and I don't have the V. Go to your formula sheet. Please go and find something that doesn't have the V. This one got V, I don't have. This one got V, I don't have. I cannot use. This one got V, also I don't have, I cannot use. Formula number 3. Yeah, there's definitely one formula you can use, and the rest you don't want. In this case, I don't want everything that has V because I do not have the V. So it'll be S equals to UT plus half AT squared. You can call it half AT squared. You want to write half GT squared, also can. It doesn't matter. AT GT is fine. 4 equals to 0 times T plus 1 over 2 times 9.81 times T squared. Anything times 0 is cancelled. 1 over 2 times 9.81 is 0. Is 4.905 T squared. Then you divide. Okay, then you go and square root your answer. Okay, done. Okay, so they are mixing your chapter 5. Sorry, your form 5. Your form 5 with form 4. Yeah, your form 5 force and motion with form 4 force and motion. Then calculate the velocity. Also a SUVAT question. Before it reached the floor. So right before it reached the floor, it will be very fast. That's the fastest speed. Again, it is a SUVAT, but this time I want to find the V. The S I know is 4, U is 0, A is 9.81. Again, you can call it G also can. And then the T also you know. You found out that it was this, right? So sometimes in this kind of case, there's too many formulas. There's too many that you can use. Because all the info you have, right? So you must cancel somebody out, because for you to do SUVAT equations, you must always only deal with 4 symbols. 1, 2, 3, 4. Including the one you want to find out. 1, 2, 3, 4, and then got one you don't want. Here you got 1, 2, 3, 4, 5, too many. Okay, so maybe I choose to cancel the T. Up to you. You can cancel the A also. You can cancel the S also can. Up to you. Okay, maybe I cancel the T. So my formula will become this one. This one don't have the T. Okay, but let's say you go and cancel the S. You don't want the S. Then you go and use V equals to U plus AT. Or let's say you go and cancel the A. You don't want the A. Then you can go and use S equals to 1 over 2 U plus V times T. Don't have A one. Up to you. The final answer will be very similar. Okay, for me, I'm gonna do cancel T one. I don't like the T, you know why? Because the T is a rounded off value, so maybe not as accurate. But it's fine, right? In SPM is all correct. So my V squared equals to 0 squared plus 2 times 9.81 times 4. Okay, you square root your answer, you will get 8.859 if you round off. Okay. If your answer is slightly different, it is okay. Maybe because you're using a different formula, it will all be correct. Part 3, state one reason why the painting is broken. Why when the painting fall down 4 meters, it will break? A very simple answer. This one, you have to think of your Form 4 knowledge. Because impulsive force is big. Because impact time is short. You know what I mean? One reason only, either you say because there is a large impulsive force, or because there is a short impact time. Or you can go and explain the meaning of impulsive force also can, because there is a high rate of change of momentum. Impulsive force is rate of change of momentum. You want to say got a high rate of change of momentum, high impulsive force, large impulsive force, big impulsive force. Oh, okay. Okay. Question D. The table shows 4 methods RSTU to pull a lorry which is stuck in the mud by two four-wheel drive vehicles. Lorry stuck in mud. We want the four-wheel drive, the smaller car, to go and pull the lorry. Okay. They say you are required to determine the most suitable method to pull lorry stuck in the mud. Talk about the angle between the cables, type of cables, maximum tension of cables, supported material below the tire of lorry. Okay, angle of cable first of all. You see, they purposely draw 30-degree, look very similar to 60-degree. Purposely one. Okay. Now, should you take a bigger angle or a smaller angle? That depends on what do you want to achieve. If your goal is to try to pull the lorry forward, then the force that you apply, the pulling force that you apply, should be as close as possible to this red color line. I want a forward force. I want to pull the lorry forward. Do you know that if let's say you apply a force like this, this force has two jobs. One of the job is to pull up here. We call it the Fy. One of the job is to pull it forward. We call it the Fx. And what should you do if you want to have more Fx? What should you do if you want to have more forward force? The trick is you apply your force as close as possible to Fx. Closer to Fx means more Fx. Let's say, for whatever reason, you want more Fy. Then you adjust your force so that it's closer to Fy. Then you're gonna, closer to Fx means more Fx. I wrote wrongly. Like that. More Fx. So guys, you make your angle as small as possible, because if this angle is small, do you agree the force will be closer to the Fx, will be closer to the forward force? right? So which is why I want a smaller angle. I want the 30-degree one. I don't want the 60-degree one. That is the main question of the whole thing. The rest, I think, is easy. It's only this one you need to know. This is your Form 5 chapter 1. The rest is easy. Okay, so between these two small angle one, I want inelastic cable. I don't want elastic cable. Because if it's inelastic, by the way, elastic usually is quite easy to break one. Like you pull, because it's so stretchy, right? You can pull it, and then it will break. And also you think from a perspective of if something is very elastic, the car keep on pulling. Later, the lorry never even move, but only the string gets stretched. So it's like you're wasting a lot of energy and force to go and stretch the string, and then you never pull the lorry. So you're just pulling the string if it's very elastic. But if it's inelastic, whatever your force is here, you will also pull the cable, and because it cannot be elastic, it cannot stretch. So therefore the lorry will also definitely get pulled forward. Okay, so the idea is you want to make sure that your force will transfer uniformly until you reach the lorry and it can effectively pull the lorry. Yeah, and then of course you want a high maximum tension lah. Meaning can tahan. This one can tahan more force, can tahan more tension. And then also you want to put a wooden plank at the bottom here because the mud is very soft. Yeah, down here you put a wooden plank so that the wooden plank can reduce the pressure. It will not press so much onto the soft mud. Okay, this is about pressure. You increase the surface area and you reduce the pressure. If you don't understand how this works, you think when you have a tire, let's say the same tire, I draw side by side for you. Both the tire maybe has the same weight, same force, acting 100 Newton. But one of it is in a mud. Okay, while the other one has a wooden plank and then the mud. What is the difference? Now, for the force is the same in both situations. That's why if you go and say force, it is not very accurate. Okay, but how come the first tire can go very deep into the mud? That is because the surface area with the mud is very small. And the pressure is very big. Big pressure means it will press very hard into the mud. All the force is concentrated at that tiny area. All the force the same force. Force is constant, force unchanged. The same force, but all concentrated to a small area. Therefore, it pressed very deep into the mud. So your answer shouldn't be about force. It should be about pressure and surface area. Okay. And of course, in the other case, your area is so big, right? Even though the mud is soft, but you have such a big surface area, therefore the pressure is going to drop. Meaning you will not press so much onto the mud. Yeah, and also this wooden plank gives you some kind of friction now, so that it's easier. This one you just keep on rubbing with the mud. Very hard to come out of the mud. This one got friction with got the grip. You can grip onto the wooden plank. So the winner is S. Okay, the winner is S. We look at the answer. Later end up S is chosen. Okay, I want small angle. Why? Because when the angle between the cable is smaller, small angle means I will have more Fx. As close as possible to Fx. How to say Fx in English? Please learn this, horizontal component of the pulling force. Horizontal component, vertical component. There's two components always, Fx and Fy. I'm just trying to say there's more Fx. And because there's more forward pulling force, you get more forward resultant force. And then more forward force means it can move faster, higher acceleration. Okay, inelastic cable. Because I want to make sure I have uniform force, uniform tension along the whole cable. When I pull, I want this force to all transfer. I want a uniform force to all transfer to the lorry so that I can pull the lorry. I'm not wasting the force to pull the cable only. Or you just say the length of the cable remain unchanged. You won't stretch the cable also can. This one is free mark. High maximum tension of the cable can tahan more force or more load, will not break easily, more durable, very strong. Okay. Lastly, wooden plank as the supported material below the tires. Reduce pressure. Got the wooden plank there, surface area increase. So you will not press so much onto the mud. That's what reduce pressure means. Or you can say I increase the grip or friction. I can grip onto the wooden block. Yeah. So S is chosen because it has small angle, inelastic cable, high maximum tension, and wooden plank. Just copy. Okay. That is question number 9. Yeah. Question number 10. The other option. Let's take a look. We have an electric cooker labeled 1000 watts, 240 volts. What is the meaning of electric current? Current is this formula. Q is charge, T is time. You put together in a sentence is the rate of flow of charge. Okay, charge divided by time. Part B, the diagram shows the cross-section of a heating element in an electric cooker. Calculate the resistance of the wire. The only info they gave is the power and the voltage. They ask you for the resistance. Okay, maybe I do the working here because down there no space. Okay, so far we got the power. We got the voltage. They say find the resistance. We go and look for a suitable formula in the formula sheet. Yeah. So electricity really got a lot, but they gave you power. I'll be thinking most probably this one because got power and voltage, but I do not have the current. I do not have the current though. And also they want to find resistance. If you look through the whole list, definitely won't be using this because we don't have all these things, but I think we can go and use this. So got two methods. Some people, they will go and sub in power, voltage, find the current first. The current, they go and sub in and find the resistance. Some people will go and combine these two formulas together. Both way also works. Okay, actually in your syllabus, we did teach you how to combine them. Power is VI. Okay, you can go and find the current. You get the same answer, don't worry. Go and find the current. And then you sub into V equals to IR. But according to V equals to IR, if you don't have the I, you can also substitute the I as V over R. And so the formula will become V squared R over R. Right? And now it's perfect because I got P, I got V, I want to find R. And so you can now say power is 1000 watts, voltage is 240 squared. I want to find the R. Multiply the R, divide the 1000. You type this into your calculator. Okay, so this way is not the only way, remember. I said you can also go and find the current. After you found the current, you sub into here, you find out the resistance. Also works. Answer will be exactly the same. Okay. That is part B1. Yeah, part B2. The electric current that flows through the resistant wire is 4.2 ampere. Calculate the power produced by the resistance wire. Okay. Now they say find the power. Please don't think that it is going to be the same power lah. Yeah, it's usually not the same power, but they gave you current. They say go and use this current. The current is 4.2 ampere. Okay. So far, we know the resistance is 57.6 ohm. That's what we calculated. Yeah. What this question is trying to ask is actually, can you find what is the power loss at the uh, heating element? The resistance wire is your heating element. Okay. Please understand, the resistance of this wire is what produces the heat. This wire will release a lot of energy as heat, will release a lot of power in the form of heat. Yeah, so it will have a lot of power loss. It will have a lot of energy loss as the form of heat. And how do you find the energy loss, the power loss? It must come from the resistance, because the resistance is what creates the heat. When the resistance is very high, I always say this wire will become hot because you are forcing electrical energy to become heat. And why the current forced to become other things, why electrical become heat? It's because the resistance here is so high, so difficult for current to flow, which is why the wire becomes so hot. So hot until you can go and use it to go and cook things, cook your food. Okay, and power loss formula is actually I squared R. Yeah, so you use this. So this one a bit tricky, huh? And you're gonna get 1016.064 watts. Yeah, this is what I get exactly in my calculator. Okay, you might think, teacher, why this one a bit higher than the original power? I supply 1000 watt, but why now I can get so much power? Uh, it's because maybe the current here they rounded off the value lah. Yeah, the current here they rounded off the value a little bit. Usually this one's supposed to be a bit lower. Okay, or maybe there might be a small error in the value that they gave, but if we just follow the value, this is what I'll get. Okay, can. And then part C, explain how heating element of an electric cooker can be used to heat up the food in the pot. So like I said, this one is because of the resistance. If the resistance of the heating element very high, by the way, guys, I hope you know, a heating element is just a piece of wire that will become very hot because the resistance is very high. And in the formula sheet, there is a formula for resistance. That is, if you make the length of the wire high, if you choose a resistivity of wire to be high, then the resistance will be high. And if you make the area of the wire very low, the thickness of the wire very small, then resistance will be very high. A very high resistance is what will produce the heat. Okay, so your explanation can sound like this. You can start, first of all, you explain what is the energy conversion. You supply electrical energy. And then you get heat energy. You get 1 mark here. Then you can see the heating element is always a coil shape like this. We coil it for a reason, because when you coil very long like that, the length will become greater. Yeah. Coil, maybe I talk about that. Coil shape heating element increases the length of wire. When the length is greater, the resistance will be high. Or maybe it's worth mentioning that heating element, I always choose a material like nichrome, because nichrome has very high resistivity. Heating element is made of high resistivity wire. You want to talk about thick, you want to talk about the wires usually very thin and also can, but the greater length and also the higher resistivity is what produces a higher resistance. Increases its resistance. Okay. High resistance wire can produce a lot of heat. Wire, you can say wire or heating element, can no problem. Produces a lot of heat. Finally, how do you heat up the food? When the wire is hot, the heat will transfer to the pot and then transfer to the food. Okay. Heat from the heating element is transferred to the pot, then to the food. Okay, so you talk about energy conversion. You talk about the coil shape, increase the length. You talk about I use high resistivity wire. You talk about how does it increase the resistance. High resistance can produce a lot of heat. And then how you transfer the heat to the pot is how you cook it, how you cook the food, heat up the food. Okay, while it looks quite long, please understand when you read the question, you think about what are they trying to test you? What are they trying to ask? They are trying to test you this. They're trying to ask this. How to produce the heat? You force electrical energy to become heat by making the resistance so high. Okay, this is a very, very common and popular idea that they love to test in electricity. Okay, part D, the heating element in the diagram does not last and needs longer time to heat up the food. The table shows some different characteristics. Okay, guys, the answer is based on, again, mostly is this formula. Think how to make the resistance high. And you want a coiled wire, right? Because that is longer length. You want high resistivity. And you already know the answer. Okay, must be nichrome. This one you must remember because nichrome has high resistivity. Okay, the opposite of nichrome is copper. You must memorize this too. Nichrome, high resistivity, copper, low resistivity. Let's say we are not trying to produce heat, you're just trying to produce a normal wire, then I would want copper. Copper is the best, low resistivity. These two must know. The rest don't need, we never use the rest to talk about resistivity one. Okay. Lastly, casing of material. I feel steel or copper both also can, but one thing good about steel is that both also good heat conductor, but steel don't rust. Especially stainless steel don't rust easily. Okay, so you use it as the casing material. The casing is like the cover for the heating element. The heating element is down there, and then I need to cover it with a steel, and then only I put my pot on top. Okay, so clear winner is L. Coil shape, because coil shape is higher resistance, longer wire can produce more heat. Either one is already correct. High resistivity, because high resistance produce more heat. Nichrome, high resistivity, high resistance. An extra info, nichrome has a pretty high melting point, will not melt easily, very good as a heating element, can produce a lot of heat. Steel casing material, don't rust, don't oxidize easily. Pretty good heat conductor. But copper also quite a good heat conductor, but this one you can still write. Can withstand high temperature. Yeah, so L is chosen because of all this. Yeah, coil shape, high resistivity, nichrome, steel casing. Okay, the essay, in my opinion, is a pretty simple one if you understand the whole idea on this. This kind of essay is one of the most popular in chapter 3. Okay, very common, like they love to keep on recycling something similar to this. Yeah, section C, question 11. The diagram shows a hydrofoil board that contains a surfboard with a hydrofoil attached below it. When the board moves, the shape of the hydrofoil causes it to be lifted up. So down there got hydrofoil. This one is the surfboard. Okay, this is due to Bernoulli's principle. Okay, so when you move in the hydrofoil, when you move in the water, the surfboard will get higher and higher and higher. Yeah, this is the water. At first, it is on the water one. But then, because water flow faster and faster and faster, the whole surfboard will start to go higher and higher and higher. You can go and look for like YouTube videos on this. At first, it's on the water, then they start to move, and then you go higher and higher and higher and higher. Then the whole surfboard will go very high. So one very good thing about this is that when the whole board is not touching the water, you have very little water resistance. You are not touching the water, so very little water resistance, and you can move quite fast. Yeah, Bernoulli's principle is talking about when this one, velocity increase, pressure decrease. When the velocity of the fluid increases, the pressure in the fluid decreases. Okay, if your sentence sound a little different, it's fine. But as long as you mention this, one increase, one decrease, correct already. Okay, please do not say inversely proportional. It is not. It is just increase, decrease. It is a lot more complicated than inversely proportional. Yeah, which we never learn in our syllabus. It is not inversely proportional. Don't say that. So it's one increase, one decrease. Not everything that increase, decrease is inversely proportional. You can also add and vice versa if you like. Yeah, but usually like this is already good enough. Vice versa meaning velocity decrease, then pressure increase. Okay. Part B, explain how the hydrofoil can cause the board to be lifted when the board moves forward. Okay. Now, I did remember that a lot of students ask me, teacher, this one very, very difficult because very but I don't really know how to do. I only know about aerofoil, which is the aeroplane wings. I don't know about hydrofoil. But guys, the same thing lah. Aerofoil is for air. Hydrofoil is for water. And then, if you know it's about Bernoulli's principle, you definitely have to explain about the velocity and the pressure. Okay, now you think, the next problem is, teacher, I forget already. Which one has higher velocity? Which one has lower velocity? Which one got higher pressure, lower pressure? Let me just tell you one thing. You don't have to memorize. You just need to know, are you trying to get an upward force or downward force? And for a hydrofoil, we want an upward force. We want a lift force. Another question, if you want a lift force, should you have a higher pressure or a lower pressure at the bottom? In order to get a lift force, down there must be high pressure. Agree or not? Common sense tells us that if the bottom is higher pressure, the higher pressure will push the hydrofoil up. Up there is low, down there is high. Down there would push it up. You want it to go up, down there must push it up. If you want it to press down, then on top must be high pressure to press it down. Right now, you want to push it up. Okay, so I got high pressure. And what does Bernoulli say? When pressure is high, it means here is lower velocity. Here on top is higher velocity. Guys, you talk about the velocity, the pressure, confirm you get some marks. 100%. Velocity 1 mark, pressure 1 mark. You say because the pressure is different, another mark, you get a lift force, 4 marks already. This is how you lift it up. Okay, so I write here now. The velocity of water, maybe I say the one on top, or you want to say the one at the bottom also can. The velocity of water above the hydrofoil is higher. Or it's higher, is greater, also can, than below the hydrofoil. Okay. Then the pressure of water above the hydrofoil is, okay, on top there is low pressure. Pressure above the hydrofoil is low, down there is high. Is lower than below the hydrofoil. Because of this, you get a pressure difference. The pressure difference, you can say between the top and bottom, but pressure difference produces a lift force. Yeah, because you already say one higher, one lower pressure, pressure difference produces a lift force. A lift is the proper name. We don't call it buoyant force. This is called lift force. Okay, so far how many marks you get? You already get 4 marks. 1, talking about velocity, talking about pressure, talking about the pressure difference. Top and bottom different pressure, you get a lift. 4 marks. Okay, got one more point you can add. The reason why the board can lift up. Now you say you got a lift force at the hydrofoil, but why this board will go higher is because you can talk about the force a little bit. Overall, your lift force is higher than the weight. Okay. The weight, I'm talking about weight of surfboard, all the weight of surfboard plus hydrofoil plus if you have a human here, the total weight. Okay, compared to the lift. So the final point I write here, why can go up? Because the lift is greater than the weight. As the lift force is greater than the total weight, we get an upward force, an upward resultant force. An upward resultant force is produced. Okay, so the last mark here is talking about if your lift bigger than W, that's why you get a upward resultant force. Okay, so the upward minus the downward force, I will still get some resultant, that's why I can go up. Okay, that is how I would answer. But writing the Bernoulli stuff alone, you already get 4 marks. Yeah. Let's see. Diagram 11.2 shows a motorized surfboard. Usually a surfboard got some motor down here to push the water and then it will go forward without a hydrofoil and moves in 5 seconds. And then in the next page, we show a motorized surfboard that moves in 5 seconds also. Okay, the power all the same now. It's just that in 5 seconds, both also 5 seconds, one of the guy here move more than the other because one has a hydrofoil and one don't have hydrofoil. So that's the only difference. Got hydrofoil and don't have hydrofoil. They say, compare the height of the surfboard from the water surface, compare the water friction acted on the surfboard and the speed of the surfboard. Guys, this one is what I mean. You must copy out what you want to compare in essay question. Structure you write or don't write is okay, up to you. But essay question, you must copy what are you comparing. So I copy all these things. Okay, one by one. Height of surfboard from water surface. This one, the surfboard quite low. This one, the surfboard is higher. Yeah. So diagram 11.2 is lower than 11.3. The water friction acted on the surfboard in diagram 11.2 is higher. More friction. 11.3 never touch the water surface, less friction. Okay, so 11.2 more friction. The speed of the surfboard in diagram 11.2 is less than. This guy is slower. You see, in 5 seconds, it traveled less distance compared to this guy in 5 seconds. Right? So according to all my comparison, they ask, can you go and relate height of surfboard from water surface and water friction? Also relate water friction and speed of surfboard. Okay, so I'm going to say height and water friction. If the height is smaller, then the water friction is greater. One small, one big. So you can say one small, one big, or one big, one small. It doesn't matter which one is big and small. Just one increase, one decrease. So if you got a greater height of surfboard, that means the water friction is smaller. Like this case. You go higher because less water friction. Water friction and speed. If you got less water friction, then you will move faster, greater speed. Or you want to write, if you got greater water friction, then you got smaller speed. It doesn't matter which one is greater and smaller, just one up, one down. Okay, just one up, one down. And then last one, part D. The diagram shows a hydrofoil boat this time that moves in the sea. Instead of surfboard, now I do hydrofoil boat. You are required to design a hydrofoil boat that can move faster, carry more passengers at the same time and safely. Now guys, try to not repeat this again. Don't say carry more passengers, if can. Suggest and explain your suggestion. State and explain, your suggestion based on characteristics, size of boat, characteristics, size of hydrofoil, and also power of engine use, number of hydrofoil attached. Okay, so got how many things they ask you to say actually? Characteristics of boat, size of boat, characteristics of hydrofoil, size of hydrofoil, power of engine use, number of hydrofoil. Hey, this is a very rare question. They give you so many points, but 10 marks only. So you just mention any 5 correct and 5 reason correct, you already get full marks. So in my opinion, this question is not hard. This question is really not hard. It's very easy to score full marks. Let's take a look at what are some of the things you can say. Starting with characteristics of boat first. Low density, lighter, low mass. I already get 1 mark. Characteristics. You can say low density 1, you can say I want a strong material, can or not? Or a steel material, aluminium or aluminium alloy. Does not break easily, does not leak easily, very strong, more durable, does not rust easily, can. And then also on characteristics of boat, small mass, lighter boat can accelerate more. Because when your mass is small, why acceleration is big is because of F equals to ma, right? Not? When your mass is smaller, your acceleration will be greater, considering you apply the same amount of force. A lighter object easier to accelerate. Still talking about characteristics of boat, aerodynamic, less friction, less drag. Yeah, big size of boat. Now we talk about the size. Okay, big size of boat. Greater buoyant force. Displace more water, can float. Now guys, the boat is at first on the water surface one. So a bigger size means, yeah lah, some people say can carry more passengers, but don't repeat this again. Bigger size means easier to float. Small boat, very easy to sink. Why? Because bigger boat, you can displace a lot of water. You can have a lot of buoyant force. But then the moment you start to turn on the motor, the moment you start to move faster and faster and faster, now slowly the whole boat will start to rise up because there is the lift force. So the entire boat will be lifted off the surface, just like this surfboard. Okay, the whole thing will be lifted up. So you want big size, small buoyant force and all. Low density of hydrofoil. Lighter, lower mass, higher acceleration. Small mass of hydrofoil. Lighter hydrofoil. Can accelerate more. Strong hydrofoil also can. Aluminium hydrofoil, steel hydrofoil, fiber plastic. Does not break easily, does not rust easily. So many repeated reasons. Many hydrofoil. Oh yeah, I noticed one thing already. I know why I got so many points. The size of hydrofoil is a typo. Yeah, it's they only mention characteristics, but right don't have size of hydrofoil. So actually, sorry, only 5 points. Okay. You also can say bigger size of hydrofoil, but usually more helpful if you add more hydrofoil. Hydrofoil, what is the purpose? Lift force. To lift you up, produce more lift force. More lift means less air, less water resistance. So boat will move faster, right? More momentum, more energy to move faster. Can lift up more. Higher power of engine. Bigger power means more forward thrust, more forward force, push you forward more, more energy, more momentum. Uh, they also accept buoyant force, but I feel buoyant force is not the best to talk about. I feel lah. Yeah, but they did accept it that year. Right? So many things to say. So many points. You just need any five and 5 reasons. You get 10 marks. Okay, Ken. So that is the end of this 2021 paper 2. I'll see you in the next one. Good luck in your exams.